In this video, I would like to present you mppR, an R package for QTL analysis in multi-parent population diploid organism. mppR can be downloaded from CRAN. mppR is dedicated to the analysis of population composed of cross or family like nested association mapping, diallel, or breeding population, which are a collection of cross between a set of parents. Different models are possible. The first one, the cross-specific model, assumes that the QTL effect is different in each cross. The parental model assumes that each parent carries a unique allele. In the ancestral model, we assume that parents that are genetically similar carry the same allele inherited from a common ancestral source. Finally, in the biallelic model, we assume two alleles corresponding to the two SNP marker score. To illustrate mppR, we use the subset of the USNAM data available there. To use mppR, the first step is to gather all sources of raw data information in a single mpp data object. To do that, you can use the function create.mppdata, which take as argument all sources of raw data information. First, the genotype marker matrix of the offspring and of the parent. So GenoOff is the genotype marker matrix of the offspring. It is organized with offspring genotype as row and as column the different marker, and the marker score are scored with 2 letters, 1 letter per allele. Then the genetic map, a 3-column data frame with marker identifier, chromosome and position in centimorgan. The phenotypic information, a numeric matrix with 1 column per trait, cross.int, a vector that specifies to which cross each offspring genotypes belong, and par per cross, a character matrix with 1 letter per cross with the cross identifier and the 2 parents of the cross. When you have all your data, you can create the mpp data object, and when the mpp data object is created, you can perform some quality control to make sure that the data have a correct format. Then you need to transform the genotypic information into IBS and IBD genetic predictor. The final step is to cluster the parent. For that, you can use the R package clustaplo. The easiest solution is to use the version of mppR that is available on GitHub, because in that case, the function parent cluster contains some functionality to directly call clustaplo to perform the clustering and to store the information in the mpp data object. Then you have a complete mpp data object, and when your mpp data object is ready, you can perform the QTL analysis using mppproc. One important argument of this function is QF, which specifies the type of model you want to run. This function performed a full QTL analysis with simple interval mapping, composite interval mapping, and for the detected QTL, calculate the genetic effect. The results are stored in the output location, and you can have a QTL profile, a visualization of the QTL effect along the genome, and a small report with, for each QTL, the estimation of the genetic effect per parent or per cross. You can also perform some cross-validation in mppR and some multi-QTL effect model. In that case, you will allow the QTL effect to change at different positions, for example to be parental, ancestral or biallelic. For further information, you can have a look to the GitHub repository and to the vignette of the package. Here you can find some final reference and link.